Hello, everybody. Here is the t-test right here. Okay, so the problem says a sample of 10 11-year-old students and 10 16-year-old students were each given a questionnaire to determine how many books each of them had read in the previous year. The aim was to find out whether older students generally read fewer books than younger students. The results obtained were summarized as follows. Okay, so first of all, we need to write the null and alternative hypothesis, and on page 1, we already did that. So go back to page 1, find this example. Yes, this is the one where we chose the one-tailed t-test. We'll talk more about that in 1 second. Here is the null. Is no difference between the number of books read by the 11-year-old students and the 16-year-old students. Null. Okay, cool. And then I will just grab the alternative. Boom, 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 boom. There's a fast way of doing that, I just realized. And there we go. Okay, and here's the alternative. Hypothesis: the amount of books read by the 16-year-old students is less than the amount of books read by the 11-year-old students. Now, when you're looking at answer keys for the IB, they're going to show this in a different way. They're going to label this 1 and this 2. Doesn't really matter which one is 1 and 2. The null is just saying that the average, and we write the average as x hat of 1. This mouse pad is very different from my other one, is equal to the average of 2. This is basically saying that, yeah, both sets of numbers are roughly equal. Their averages are roughly equal. Now, in this one, though, the alternative, this is, we want to know if the second one is less than the first one, or the first one is greater than. We want to know if the younger students are reading more than the older students. Again, this mouse pad is killing me. All right, x2 bar. Okay, and right there, this is what makes this a one-tailed test, right here, because we're testing to see if one or the other data sets is either greater than or equal than, greater than or less than the other one. Cool. Write down the null and alternative, perform a t-test at the 5%, write down the conclusion. Well, that's straightforward. Okay, let's go back to the calculator right here. What am I going to do? I need to, yes, always looking for a way to delete faster. Let me know when you found it. And there we go. Okay, so I think what we want to do, if I remember correctly, is put in list 1. All right, my 11-year-olds, 18, 10, 3, 18, 10, 3, and 15, 12, 14, 15, 12, 14, and 15, 4, 20, 15, 4, 20, and then 8. All right, that's list 1. Cool. Let's go to list 2, our older students, 6, 7, 14, 6, 7, 14, and 5, 14, 12, 5, 14, 12, and 3, 9, 4, 7, 3, 9, 4, 7. We've got them. We've got both our sets of data right here. Now, the t-test, I believe you'll go to test right here. You'll go to t-test. You'll choose 2 sample, because we have 2 samples of a t-test. We have 2 samples of data. Now, here's the big importance here. So we want to test again. Our alternative is if the 11-year-olds read more than the 16-year-olds. So list 1 is greater than list 2. That's what I have to get in here. And that's nice of my calculator. It's already in there. So if it was just saying not equal, no, we'd want to know if list 1, the 11-year-olds are reading more than the 16-year-olds. Okay, remember to check one thing when you do t-tests. Remember, the pool has to be on. It cannot be off. good chat. Okay, so I think that's all I really need to do here. It's got the two right lists. It's got the correct alternative hypothesis. I'm gonna execute this. Cool. So the value is this. We don't really care about the t value, but the p value. Oh, that's very interesting. 0.0499. Wow. Were we doing a 5%? Of course we were a 5%. That's very close to 5. Okay, so p-value here is 0.499. Wow, that is close to 5. Wait, did I do that correctly? Yes, I need to put a 0 right there. 0.0499. So, because our p value is less than our significance level, we can reject the null hypothesis. 11-year-old students do read more than 16-year-old students. Okay, it's probably a good idea to note p-value extremely close to our significance level, and therefore I think that it's I think it's healthy to kind of put some doubt on that result, and therefore our result could be in doubt. I think that's a good thing to mark down there. Okay, conclusion of the test. We rejected, and I think we're all good, folks. Thank you very much.